This is the second part about the calculation of moment. And in this part, you'll understand how can we resolve the given forces to calculate the moment. For example, if a rod is here and the rope that is supporting the rod, for example, if this is the rope, if this is the rope and let's suppose this angle is 60 degrees, this angle is 20 degrees. Now the forces on the rod are, for example, the rod is uniform and its length is, this length is L. So we'll say that the rod is uniform, which means that the weight will act in the center. The rod is uniform and the weight of the rod will act in the center. Because the rod is uniform, so weight of the rod will act in the center. Now the question is that calculate the moment due to the weight mg and tension in the rope T. So calculate the moment due to the weight mg and tension in the rope T. This is the question. First of all, if we represent the forces on the rod, the forces which are acting on the rod, they are if this is the wall, and the forces which are acting on the rod, they are one of the forces is the weight of the rod that is acting vertically downwards, and this weight of the rod will be acting in the center, like on this side, and on this side this would be half of the length of the rod. And as you know, this angle is given as 60 degrees. So this angle, they are called the corresponding angles. This angle will also be 60 degrees. So this is mg, which is acting in the center, and the length of the rod is divided in two parts. Each part is L by 2. Now in the rope, for example, if this is the rope, then the tension in the rope is away from the object on which it's acting. Tension is basically a pull or a pulling force, and in the rope, the tension is away from the rod. Now let's calculate the moment due to the weight and moment due to the tension individually. For example, if we want to calculate the moment due to mg, so we'll calculate the moment due to mg. That would be, this is the wall, if this is the wall, and here you have These are the two ends of the rod. And if we go for resolving of forces, the weight of the rod is acting vertically downwards, and you see the angle of the weight or the angle of the rod, the length of the rod is L, and its angle with the vertical is given as you see it is 60 degrees. So this angle of the rod with the vertical is 60 degrees. The other force that we have to see was the tension in the rope that is attached with the rod and supported by the one of the angles that is given above was 20 degrees. So if this angle is just, for example, 20 degrees, then this angle would be 100 degrees. So no, in fact, this angle is not 100 degrees. This angle would be, it is 60, it would be 120. Then 120 plus 20 becomes 140. So if these two angles, they make a sum of 140, the third angle will be, is 40 degrees. The reason being, sum of angles of a triangle is 180. Now the tension is T. Now you see here, there are two forces. Weight is vertically downwards and the tension is acting at 40 degrees to the rod. To find the moment of any force, you need to resolve that force along the rod. For example, let's go with the weight. Find the moment of the weight. This is the wall, and the weight is vertically downwards. So the weight is a force which is acting right here, vertically downwards. And this length is L by 2. This length is also L by 2. So both the lengths are L by 2 and L by 2. Weight is acting in the center, and the angles which we have, this angle is given as 60 degrees. In all the examples, this angle is 60 degrees. If this angle is 60 degrees, then this angle will also be 60 degrees. And this is the line along which the displacement or the distance is given. The distance L is given along this line. So we need forces along this line. If we resolve the weight along this line, one component would become this component. This component would become mg cos of 60. The other component that is perpendicular to the rod right now, it is this one. So this component would be mg sine of 60. The component that is along the rod or along the distance is to be ignored. The component that is perpendicular to the distance is to be taken. Now the moment will become moment is equal to, so moment will be equal to, it is a component of the weight that is perpendicular to the distance. That component is multiplied with the distance, and right now you see that the distance of weight from the pivot is L by 2. Now when you look for mg sine theta and mg cos theta. Mg cos theta is along the weight and it must be ignored. So while calculating moment, you have to care about this fact that if there are multiple forces, then if forces are along the motion or along the oscillation, if forces are along the distance, if a given force is along the distance, ignore it. So the forces that we take, they must be either parallel or they must be perpendicular to the distance which is given. However, in the given example, if the weight is resolved with the mg cos 60 and mg sin 60, mg cos 60, mg was here, and the components are so the components of mg will be the angle of mg is 60 degrees. The components would be mg cos of 60, and this component will become mg sin of 60. And this distance is L by 2. Because of this distance being L by 2, if we take this L by 2, then it is to be ignored. If we take this side of L by 2, then it is to be ignored. Now, after resolving, what is the status? What will be the moment of mg? The moment of mg, if it's to be calculated, then you have to focus on the components. Mg cos 60 mg cos 60 is along the given distance. So mg cos 60 is always the distance, and can be multiplied to mg cos 60 is along the distance and can be, it can be ignored. You're supposed to ignore that. And it must be or it can be ignored. So if some force is along the distance, it is to be ignored. A force that is perpendicular to the distance is to be taken. For example, now this weight is resolved into two components. One of them is the perpendicular component, and the distance of perpendicular component from the weight is L by 2. So it would become moment due to weight moment due to mg will become mg sin of 60 into the distance that the moment due to mg will be mg sin of 60, and its distance from the pivot is L by 2. So this is the moment of mg. This is the moment of mg. Now the other force that is acting is tension. Moment of tension represented as T. For that, you have resolved the tension. If we resolve the tension, what it will become? This is the wall, and if the tension is resolved, then the values of angles are given, so it would be an easier question. The tension is in the rope, and you see the rope is, for example, the rope is here, and the forces are, one of them is tension, and now we are doing it for tension. So the moment of the tension, for that we will resolve the tension. So for example, the rope is, so this is, the rope, and the angles which are given in this question, they were, so the angles which are initially given, they are, so the angles which were given initially, they were, this was 60 degrees and this was 20 degrees. Let's suppose if this angle is 60 degrees, the angle that is above this one will be 120 degrees. So the angle that is missing, it would be, one second, it would be 20 and 60, 80. So this is 60, this would be 120. So this is 120 degrees and this is 20 degrees. So it makes 120 plus 20, 140, and the remaining one is 80 degrees. In fact, this is 60, this is 120 because the sum is 180. So it will remain 60 minus 180, it is 120. Now in the triangle, you have three angles, 120 and 20 and some angle which is missing. So now you see, if you add all the angles, saying this is theta, then 120 plus theta, 120 plus theta plus 20 is equal to 140 plus theta. So theta would be equal to the angle in the row. So theta would be equal to the 40 degrees. So it would be, the overall angle is, so this is actually 40 degrees. As you see, this is 20 degrees, this is 120 degrees, 20 and 120 is 140, and the sum should be 180. So 140 and 180, 140 and 180, the difference is of 40 degrees. Now these are the angles. These are the angles, and the angle that was missing is 40 degrees. Now we will resolve tension with this 40 degrees. With the row of the angle, the tension is T. Now to calculate the moment for T, we have to resolve T. So you must resolve P into its components. That would become, so this was a rod. Now if we resolve tension into its components, this angle is 40 degrees. So this component of tension, so this is at 40 degrees, this component would be so this component is t cos 40, and the component that is perpendicular, this component will become t sine of 40. So t cos 40 is along the angle and t sine 40 is perpendicular to the distance of the rod. We'll say that t sine 40 is along the distance. So, sorry, t cos 40. T cos 40 is along the distance. So, it is ignored. T cos 40 is along the distance, so it is ignored. The moment will be due to t sine 40. So, moment will be equal to t sine 40 times t sine 40 times the length of the rod. So this is the moment caused by the tension, and in this manner you can calculate that. One other example for the calculation of moment, for example, you have this wall on the left side and there was another wall so there are two walls and a rod is balanced between them in such a way that here you have a rod so this is the rod and tension in the rope is for example T. The rod is uniform, so the weight is acting in the center. The length of the rod is, for example, D. The length of the rod is D, the weight of the rod is acting at the center, and the tension in the rope is T. And the angles which are given in this question, this is a new question, a fresh question. This angle, which is already given, it is 60 degrees. And this angle is also this angle is also, for example, this angle is, for example, 70 degrees. Now, if this angle is 70 degrees, then how will you find the moment of weight and the moment of tension? First step is to find the angles. To find the angles, you should draw references at the point of action of forces. For example, if I redraw this drawing again to find the moment of the weight and the moment of the tension, this is the position of the rod. This is the position of the rod. And with this rod, this is the weight. And as you see, the angle of the rod with the vertical, this angle is 60 degrees. Now, if you resolve the weight into two components according to this angle, and the length of the rod, here it is T. So the length of the rod is T. Now, weight can resolve into its components, and then we can calculate the moment for the components. The sum of moments of components of a force is equal to the moment of the force. So if we resolve the weight, because the weight is not perpendicular to the given distance, if we divide the distance into two parts, The first part is d by 2 and the second part is also d by 2. So this is weight. If we resolve weight into two components, the two components will become, this angle is 60, so this angle will also become 60. One component of weight is here and the other component of the weight is perpendicular to this distance. So the component which is along the distance, it would be mg cos 60. And the other one, the perpendicular component would be mg sin 60. Now out of these two forces, mg cos 40 is to be ignored and mg cos 60 is to be ignored and mg sin 60 is to be taken. So both the distances on the two sides are d by 2. So it is a product of force and perpendicular distance. Mg cos 40 ignored along the motion. Mg is not perpendicular, so ignored. So moment of weight about the pivot, this is the point which is pivot. So moment of the weight against the pivot or about the pivot will become moment of the weight about P. It would become, this is point P, mg sine of 60, use the component that is perpendicular and multiply it. Mg sine of 60 should be multiplied with d by 2 to calculate the moment of the weight. Now this was the moment of the weight above point P. Now let's go with moment of the tension. So moment of the tension. Tension is another force that is acting on the rod and it is a pull or a force that is away from the object on which it acts. Now we just represent the tension. For example, if this, so this is the rod and it is supported by a rope. The tension in the rope is T and the angles which are given in the original question, they are, here you have 70 degrees, here you have 60 degrees. Now if I draw a vertical line here, then the angles that I can write easily, they are, this angle is 70 degrees and the angle with the line of the rod and the tension will be, if we look at the given possibilities carefully, then this angle is obviously 60 degrees. So the angle above is 70 and this angle is 60 degrees. The reason being, if you have two parallel lines, then these angles become equal. For example, if these are the two lines and you have this angle, if this is theta, then this angle will also be theta. So the angle of the tension with the line of the rod will become 60 and 70, it's 130. Now it is 50. Now it is 50. I hope you understand how we get this 50. So once you found the angle, the next step would be resolve the force. Once you found the angle, the next step would be resolve the force. For example, this is the object, is gap or length is d. And the force that is achieved, it is the tension in the rod. And one thing is this angle was, as you see, 70, 60 and 50. So this angle would be 50 degrees. So if we resolve the angle, if we resolve t with respect to this 50 degrees, then we have two possibilities. This is t cos 50, and the one that is perpendicular would have been t sine 50. So the component which is along the distance is to be ignored. The component which is perpendicular is to be taken. So moment due to t, if you want to calculate that, then t must be resolved. The components of t will become so if we resolve t into its components, the two components are t cos of 50 and t sine 50 if the angle is 50 degrees. Yet t cos 50, which is along the distance, is to be ignored. The one that is perpendicular is to be taken. So it would become moment is equal to t sine of 50. This is the component t sine of 50. T sine of 50 into cos t sine of 50 into the distance is, you know, is L by 2. The distance is L by 2, so it would be t sine of 50 into L by 2. So this would be the equation for moment due to t. Now moment due to t will become t sine 50 into L by 2. Now we have moment is equal to t. So moment would be t sine 50, which is perpendicular, must be multiplied with the distance along, that is d. So this is moment about point P. From here on, we will start in the next slide.